guys. As usual, we are going to analyze the question in detailed way. The question is taken from CSIR December 2019 Chemical Sciences. I know you already have answer key and you may have the concept of it, but just watch it again. You may get extra information from this video. Now just look at the given problem. True statement for the following transformation is, here we have 4 pi system reacting with 2 pi system under heating conditions, that is 4 plus 2 cycloaddition. We know the name of it, Diels-Alder reaction. Okay, right. And we know that Diels-Alder reaction is a spontaneous reaction. Okay, now just look at the basic definitions of entropy and enthalpy. So what is entropy? Simply here we can say the energy of disorderness. Okay, the energy of disorderness not available for work in a thermodynamic process of a system. So simply here the randomness of a system considered as entropy, right? Now just look at the reaction. 2 molecules of reactants are combined to produce 1 molecule of product. Now delta S will be entropy of product minus entropy of reactants. So simply 1 minus 2 resulting minus 1. So we can say delta S must be negative. Okay, now for a spontaneous reaction, if delta S is negative, then delta H must be negative. And we know the Diels-Alder reaction takes place at room temperature, that is at low temperatures. Okay, we can say simply at low temperatures. Now delta G will be negative, and whenever delta G will be negative, then the reaction is spontaneous. Okay, now just check why and how delta H will be negative for this Diels-Alder reaction. I just consider a simple Diels-Alder reaction in between cis-butadiene and ene. Okay, right. Now here in this reaction we can say 2 weak pi bonds. Okay, so just consider 2 weak pi bonds converting into 2 strong sigma bonds. Okay, here is a formation of new strong sigma bonds, right? So simply 2 weak pi bonds are converting into 2 strong sigma bonds. And just whenever we look at bond changing energies, for example, a single carbon-carbon bond changing energy worth about 65 kilocalorie per mole. Okay, and at the same time one single carbon-carbon double bond changing to carbon-carbon single bond, here we can simply say that 80 kilocalorie per mole. Okay, now just apply here. We have 3 pi bonds which are involving in cycloaddition reaction. So 3 into 65 kilocalories, that means double bond is converting into strong sigma bond. That's very easy to break this pi bond here. So that's why less energy required. We can say 65 kilocalories. Okay, right. Experimentally it is approximately 65 kilocalorie per mole. So 3 into 65, 195 kilocalorie per mole. Now just consider here, new 2 sigma bonds are formed. Okay, and 1 pi bond. So 1 pi bond equals to 65 kilocalories plus 2 sigma bonds. So each sigma bond formation required almost 80 kilocalorie per mole. So 2 into 80. Okay, so the total will be 225 kilocalorie per mole. Now just take the difference here. So 65 here 195 minus 225 kilocalories, almost minus approximately minus 35 kilocalories of energy. Okay, so that is indicating that delta H, a change in an enthalpy. So what is enthalpy here? Heat content of a system under a given pressure. Okay, so first the reactants are having the energy as 195 kilocalories, whereas the product is having the energy 225 kilocalories. So which is going to release the energy as approximately 30 kilocalorie per mole. That's why the Diels-Alder reaction is considered as exothermic reaction. Now just check here, delta H and delta S. So delta H must be negative, delta S must be negative, then only the free energy change delta G will be negative and reaction will be spontaneous. So here Diels-Alder reaction is spontaneous. Now just check the option. Second option is the correct answer. Okay, right. And if you are interested, just visit chemmasters.online and join on concept oriented courses. Thank you very much.